Hello students. In this chapter, motion in a plane, we have studied about vectors because this concept of vector will be applied very frequently in the motion of any object in a plane. So vector aspect is clear to all of you. Let this be a reference frame in this plane, that is x, and this is y, and unit vector along this is I, and unit vector along this is j. It is x axis, we will say, of this reference frame. This is y axis, and unit vector is j along this. And in the motion of an object in this plane, this is the plane, this is the reference frame. So here first, what is required pertaining to motion of an object? That is position of the object first, then the velocity of the object, then the acceleration of the object. These are the physical quantities and status of an object when it is moving in a plane, right? So first we will talk about position of an object. Let's suppose the object is moving this way. This is the path. This is the path along which the object is moving. So we can specify the position at various places, right? By the coordinates of that particular point. Suppose the object is here. Suppose this is the position P. So with reference to this frame, this is the origin. So let the coordinate of this point is x, y. So its position is specified by the coordinate of this point with reference to this axis. Now in terms of vector, it can be specified by, this is position vector. Let this position vector be r. So position of this point will be given in the form of coordinate as well as the position vector. And we know that this position vector is specified in terms of the coordinate of the point x and y. See, if you draw perpendicular from this position of the object on x-axis, this is 90 degree, suppose it is q, then this vector r is sum of these two vectors which are mutually perpendicular to each other. So we can write that OP vector. OP vector is equal to OQ vector plus QP vector. So what is OQ? OQ is the x coordinate, that is x, and QP is y. Means length of this vector is x, length of this vector is y, and OP vector is r. Therefore this r vector can be written as magnitude multiplied by unit vector along this direction. So it is xi plus, in the same way, it is yj. So position vector is specified in terms of coordinate of the point and the position vector, and that is written in this form like this. Now this is about the position of a moving object, that is position of an object in this plane, right? So motion is like this, and at particular position, if the coordinate is xy, then this position vector can be written as r is equal to xi plus yj. Now we will talk about displacement of the object. Now displacement of the object moving in a plane. So here we will take the displacement of a moving object in a plane. Again, this is the reference frame, this is the origin, this is x-axis of the reference frame, this is y-axis of the reference frame, and the unit vector is j, and this direction unit vector is I. And the motion is like this. Object is moving this way. In this plane, this is the motion of an object. We will see the two positions of the object. Suppose this is the one position P1, and then after some time it reaches at P2. Then what is the displacement we will look at? Suppose this is the position vector of, that is position vector is r, and when it reaches over here, the new position vector is r1. R is the position vector initially at certain time t, then after some time it came to P2, right? And this position has got the position vector r1. And here, suppose the coordinate is x, y for this point P1, and for P2 coordinate is x2, y2. We will say it is x1, y1. x1, y1 is the coordinate of this point P1, and x2, y2 is the coordinate of the position P2. So from P1 to P2 it has gone. So displacement is this. Straight we have joined. So this is the displacement, right? Let this displacement be delta r in form of vector, right? So this is the displacement from P1 to P2. So we can write r plus delta r is equal to r1. That is triangle law of vector addition. Therefore, delta r is equal to r1 vector minus r vector. This tells the displacement, and object is moving in this plane. So displacement is clear. R1 minus r. So what is R1? R1 is, according to this rule, how to write the position vector, that R1 means x2, y2. So x2i plus y2j. R1 can be represented this way, and R can be represented as minus, that is x1i plus y1j. Means R is represented in terms of coordinate of the point P1, that is x1i plus y1j. Similarly, coordinate of P2 is x2 and y2. So R1 is represented x2i plus y2j. So we will take all i's together and j's together. So this can be written as x2 minus x1i plus y2 minus y1j. So this delta r, it is the vector represented by this. And what is x2 minus x1? See, if you draw perpendicular from here, and perpendicular from P2 on this. So this point, this is x1, this is x2, so this is x2 minus x1. Similarly, this is y1, this complete is y2, so this part is y2 minus y1. So this is x2 minus x1, this is y2 minus y1, and if it is represented in form of vector, so these x2 minus x1 I in the direction of x-axis and y2 minus y1 is in direction of y-axis. x2 minus x1 I plus y2 minus y1 j is equal to this delta r vector. And this x2 minus x1 is written as, or delta r is equal to, it is written as delta xi plus delta yj. So here x2 minus x1 is delta x and this is equal to delta y. So delta x is clear, delta y is clear, and delta r is the displacement vector of the object moving along this path from P1 to P2. So displacement concept is clear. When the object is moving in the plane, then displacement is given by delta r, and that is delta xi plus delta yj, where delta x is change in x coordinate of these two positions of the object, and delta y is the change in y coordinate of the positions of the object. Now, if the position changes from P1 to P2 and time taken during motion of the object from P1 to P2 is delta t. So we will get average velocity denoted by v bar. So from here to here, displacement is delta r. If the time taken from P1 to P2 is delta t, therefore v, it is a vector quantity, and we are putting bar over it. That is, average velocity is delta r upon delta t. And what is this delta r? That is delta xi plus delta yj divided by delta t. Now we can separate this. So delta x upon delta t I plus delta y upon delta t j. So this is giving the average velocity. So average velocity v bar, that is delta x upon delta t, I is a unit vector along x-axis, delta y by delta t, j unit vector along y-axis. This is the magnitude of the average velocity along x-axis. So this can be written as Vx, and that is average, right? That is I plus Vy. It is the magnitude only. Here it is vector, that is j. So V vector, it is average, that is given by this relation, where Vx is the average velocity magnitude along x-axis. This is the average velocity magnitude along y-axis. What is the direction of this average velocity? It is the direction same as that of delta r vector. Means direction of average velocity will be parallel to this delta r. That is average velocity. It is direction, that is v vector, this is bar over it. So average velocity direction is same as that of delta r. So if we want instantaneous velocity, instantaneous velocity means velocity of the object at a particular instant, at a particular time, what is the velocity we have to find. Suppose the object is moving along this path. I want the velocity at P1. position. So we have already studied that if delta t approaches to 0, this point P2 approaches to P1, right? So instantaneous velocity, that is, it is called or velocity, right? So it is given by this. When delta t approaches to 0, then we get velocity vector at any point. At particular instantaneous velocity means velocity at particular position, particular instant. It is given by limit delta t tends to 0, that is delta r upon delta t, right? And this is denoted by dr by dt. Therefore, instantaneous velocity v is equal to dr by dt. So this is the instantaneous velocity.